All right. Well, everybody, I want to thank you so much for joining us today for our community session with Sebastian. My name is Sriracha. For those that don't know me, I do operations here at AIM. I'm super excited to have our friend present today. We will be recording, so please keep yourself muted. If you do have a question, feel free to unmute and interrupt Sebastian. He wants to interact, he wants to engage, so please feel free to do so. And with that, passing the mic over to Sebastian. It's all you, man.
Thank you. What all it is about today is graph rags knowledge extraction, and as I just stated, I want to be more focused on the how and the principles, and what the challenges you will cope with this kind of projects instead of just a hands-on demo of hey, this is my tool and how it works and so on. We're going to talk about the principles on how to do that, on how to do knowledge extraction, which is a separate task of RAGs, and how we can use graph networks, first order logic, and so on to reason and to provide reasoning capabilities to an LLM. So I've spawned up this Hugging Face space for you guys to follow up. Couple of screenshots will be there. All the text, and I will go through this and show the relationship with an actual project. The links are here with the GitHub repo and so on. Forgive me, I thought I would be opening in a new window. If they don't work, just control click them and they will open. So yeah, the Hugging Face space is there, and I posted that in the chat. Normally, yes, you got it. So the project first. I was contacted, and Kermitor, which is here, is part of the University of Applied Sciences in Windesheim in the Netherlands. And the Supply Chain Finance Research Group, which is a part of the university, is building up that project to do supply chain mapping. And so the global idea is to be able, based on open sources, so on OSINT, to go find information about a supply chain, to provide some documents, PDF documents, annual reports, whatnot, to provide other data sources, CSV files, and other structured information to an AI, then being able to ask questions to the AI and use the AI for solving a lot of challenges and problems. I don't know who is not like muted. The K.
Yeah, folks, please mute when you come in. Thanks.
Sorry, Don. Um, so the Value Chain Hackers is a living lab, and as of September, there will be students from the university working with the application and finding more scenarios and more questions we can ask to the AI. It's an open source project, so as you will see, everything about the models, the data set that we use to train, the GitHub repo is available. There's also a website about it, so feel free to go. Feel free to also contact us or me to get involved into the project. We're looking for people to contribute and build, chip, and share together on that. So yeah, the details on the website, you can see them here. Chain hackers, here you go. Made a website about the roadmap, what the problems and the tasks are, what the solutions are, and so on and so on. So feel free to read that on your own. So I was contacted by this team, and they started by doing some tree of toads and chain of toads system, but definitely that has its limits, and the limits are mostly defined by the context size. If you're talking about giving it tens of documents and databases and tables, then the context size is going to quickly become a problem. So we needed to come up with an infrastructure, with a system to, and sorry for that zooming in, but that's for zooming in the image. There you go. So we needed basically to have a system to collect, ingest data, and then going to a UI to render it out. So collection can be done by using the Go API, which we then, so the users will ask a certain question about a supply chain, about a supplier, product, whatever. And then we will use the Go search API to go search information on the public web. We will also use the wiki and the company's website to find information about their ingredients, the chemicals they are using, and so on. When I say the chemicals, like aluminium and so on, we will go gather the page of Wikipedia to get the information, um, to get the information about those and where they are sourced from, what the production countries are, and so on and so on. So we will use a bit of Wikipedia, call it encyclopedic knowledge, which is free available and static content, but we'll also use search information to get recent info and to get web pages about that. When we're talking about companies and the supply chain, we're talking about their subsidiaries, we're talking about their suppliers and so on. And so at this point, you can use the US SEC fillings, so the Security Exchange Commission's fillings. And then another thing, we have crews that build specialized crawlers based on some pages to go crawl information like the website, but also the brand site. When we're talking about some company like Unilever, they have iced tea, they have Dove, they have a lot of brands. You need to know that it's Unilever, but from the public side of view, it's all its own brand and its own life. So they have individual sites and URLs. So you need to crawl them all. That's the brand sites. And then very often each of these brand sites has a page per product. So if you want to get the list of all the products that a group like Unilever produces, you need to go down the tree from the group page. There you get brand pages explaining each brand. Then you need to find the site of the brand. And so we have crews crew AI crews to do that of agents so that they build scrapers, sorry, to get on the internet, get all the pages that are of some interest and extract structured data out of that. And then we will provide also PDFs like the annual reports, which is 90% bullshit marketing stuff and 10% of interesting information about their supply chain. We'll store that and then do the processing, the ingestion part, where we mostly will transform this information either from flat PDFs or tables, CSV files, and so on, so that we get structurized information, CSVs, JSON, Markdown, and we will have the arrows are double-sided because this will be an iteration process where we will feed that in an LLM to extract facts, graph, node edges, links between them, and so on. Um, there's also a vector store because we do want also a typical RAG to function. So we also want to find back in the documents when we give a clear query. But the part I'm focusing on and that I will explain now is knowledge extraction, because that's yet a totally different topic than just having a RAG. Having a RAG, you split your document into chapters or sentences or pieces, and then you're gonna do a query and it's gonna retrieve the pieces of your text that corresponds to that. Knowledge extraction is another approach where you take every single page of the document you got and you ask it like extract me the most information, the most exhaustive information you can get out of this. So the approach is totally different in that sense. You don't ask specific questions to a knowledge extraction. You give it text and you ask it to extract whatever is possible, right? So different approach, different things. Then at the end we will have a RAG and a Neo4j, or name it a graph database, right? Which will be used as retrievers, and we have our UI or AI that will, based on a query, make a visualization. I will show how that works, but it will basically create a list of like I want a text box and I want a chart and want a data grid and so on. So it will create different widgets to show, depending on what the question is. If you ask what are the sales and so on, it's probably gonna give you a chart. Whenever you ask what are the ingredients in the Coca-Cola recipe, it will probably give you a text box, maybe only a text box or a combination of all these. So the UI itself is also driven by an AI, which is yet another concept, right? Maybe I pause here for a second. If anyone has a question, remarks, whatever, feel free. It's the moment.
So what are you handling in the vector stores for the chroma and the FOSS?
Documents themselves, because at some point when you answer the question from the user, you do also a document retrieval. So you also retrieve in a regular RAG fashion out of the vector stores. So we have both. We have both. First, you have the knowledge extraction, which is going to extract graphs, nodes, and links. That's going to be put in a graph database. You have facts, and that will be put in some SQL database or in a markdown. But then again, this will be fed in this structure so that now you can extract your knowledge based on a combination of all the markdowns, the ones you found, the ones you've built yourself by knowledge extraction. So the idea is really that this becomes this part of ingestion is like an iterative process. And for example, to know some extra things, it will need to create your crawler and so on. So it's gonna create a crawl, get that information into it, and get that in the loop. And then it's gonna have some facts that it deduces from the text and create a markdown out of it or index that in our SQLite database. And this can then like be fed in to the algorithm again to like, okay, now that you know that these and these are the suppliers, what suppliers are you missing? And we will see with first order logic how we can have the model question itself like, hey, I know this and this, but what's the missing link between those? Or what should I, now that I know this, what's the next step? How far can I push the ladder on the future things, right?
Nice, nice.
Um, so I think that's all clear. So just a bit of terminology here. What are knowledge graphs? A knowledge graph is a structured representation of our knowledge. It's nodes, edges, the links in between, and it's just a way to represent the knowledge base we have about a certain domain, a certain company, and so on and so on. It's better in a graph than in tables, because tables are very structured and have relationships that are like pre-built. A graph is more or less without a scheme. So you can just add nodes and edges and so on, without being constrained by the fact that there is a field or not in that table, that there is that a column exists or not, right? So a graph is much more extensible way to express things and to store them. Ontologies is nothing new. That's like out for years and years now. And ontologies are a way to define the relationships between elements and the rules that make them come true or validate that, and so on. So an ontology is basically the the schema of that knowledge graph. So I said that there is no scheme. So you could eventually add just whatever entity you want. But in our case, we want that those nodes and those links to be hard baked or to be at least backed up by an ontology, by a definition. And so that's an ontology. Then the last thing that we will use in this is first order logic. And first order logic or predicate logic is a system in math that uses quantifiers and predicates to describe rules. And I will go a little bit deeper on that with a Harry Potter example, so that everyone like understands the concepts. And then I will go on to supply chain things, right? So does that all make sense? No questions of that on that? Loud and clear. So the key components of first order logic are the constants, like persons, in this case, John and Mary. Then we got variables and predicates. So an example of a first order logic expression would be this, like loves John Mary means John loves Mary. Okay. Then we will add to that quantifiers, like you have a universal and an existential one. The universal says that for it's true for all elements in the domain. So if I say that everyone loves, so every X loves Mary, that means that everyone loves Mary. Okay. An existential one would be that someone, in all the people around the world, someone must be loving Mary. I hope for her at least, but That would be the way of in first order logic expressing that, right? So this is in the other way around. There is x is here. That's the unknown. So this rule states that John should at least love someone. Now, which is interesting is when you give that to an LLM, or if you use like simple math, now you can ask who is x, because you know that in this relationship there must be another counterpart, but you don't know it. That's x. That's the unknown. It's a variable. So the idea with first order logic is that by using some statements and some constraints, you can start to do some inference. Some logical connections will be done, but you can do some inference on your variables, right? You can try to sort out what the variables are based on a set of rules. You got functions also, like is the mother of. Then you don't have a pair because that's not a predicate, but that's like who is the mother of that would return the mother of x. Logical connections and or not implies that, and if and only if. And so that's one of the important uh, logical connections that there is, that like um, someone teaches in Hogwarts, the school in Harry Potter, only if and only if it's either a witch or a wizard, but no muggle, right? And then you got the equality sign where you can say that two nodes are equivalent to each other. Does that all make sense? No questions yet? Okay.
We've got one
So,
question in the chat for you, Sebastian.
sure.
Are LLMs good with symbolic math?
They are with symbolic, yes. With exact math, no. So, I mean, if you ask it calculations, algebra, to apply algebraic calculations, it's going to be pretty bad at that. But it's going to be pretty good in Boolean reasoning. And so these are Boolean reasoning. If this is true and this is true, then this must be true. Those kind of things. That's what an LLM can do. And if not an LLM on its own, a crew of two agents, like one emitting an hypothesis, the other one knowing about the ontology and being able to say, like, okay, for this to be true, these and these and these and these needs to be true. And then that can be bounced back to the first LLM. We can now check that out. And if it cannot check that out by prior knowledge or without hallucination, you can now use tools. You can go to DuckDuckGo and search like, hey, there's someone that loves Mary or that loves John. And so now the LLM will be able to make you the query. Who loves Mary, right? Now your LLM can formulate natural language query to go on search on to internet to who the fuck is X, or what the damn shit
And
is X,
and
right?
another example is integration. Like for derivatives and integrals, you can have LLMs take the formula integral or the formula derivative for the algebraic form, but then the actual calculation, like the numbers, it's terrible at. But it can do the symbolic,
Yeah,
calculus.
it can resolve and simplify, reduce expressions in algebra and so on. But you'd never want an LLM to do the math, even though it's like you can ask it like, what is if you deduce 5% of 100, what is it? That's definitely 100 times in the training data, he's gonna produce a correct answer. But if you ask him what is 5% of 72 million, comma 2.5, it's not gonna know that, right? That's something that he won't be able to do on its own. You can weaponize it with tools, and then it can execute. It will first make the math expression it should be evaluating, and then push that to a Python evaluator or something like that to do the math for you. But you should never rely on it to do exact math. Does that make sense?
Yeah, I
I
think
guess.
it does. Yeah. Oh, jump in.
Okay. No, no, no. I guess it makes sense, right? So,
Yeah.
um,
If you take a look at
so
the
it will
chat,
be good at doing some Boolean logic. It will be good at like checking that something is true or not by using tools, by formulating search queries, by whatever. So that reasoning is something he can do. but yeah, no math as such. But that's exactly the reason why we want to give it first order logic. And I will go down explaining that with an example of an ontology for Harry Potter, just to make sure that we all get that understanding kind of well. So, in the domain of all magical creatures in Harry Potter, we have Harry, Voldemort, Dumbledore, we have the Hogwarts, and Hedwig, right? Um, we have an ontology defining some predicates. And the predicates in this case is X is a wizard, X is a witch or a muggle, X is loyal to Y, X teaches at Y, where Y is a school, and X is the enemy of Y, X has a pet Y, X kills Y, right? These are predicates that I now can use, and by using these pieces, I can describe the entire Harry Potter story, or who's who, what are relationships between those characters in a very, very easy way and a very compressed way, right? And the ontology is about this, is to define these predicates. In these predicates, or there is nothing like when he was born or what city he was born, because that's the thing I'm not interested in, and that's what an ontology also defines. If you ask an LLM to extract all forms of knowledge and the place of birth and the date of birth are mentioned in the text, he will get them out. But I don't want that. That's not what I'm focusing on. So defining an ontology is not only about defining the rules and so on, but also telling him, hey, that's the things I'm interested in. All the rest you can find in that document doesn't make sense for my use case. So forget about that. That's not what I'm looking for. So the function is master of, right? Then we can start to define some axioms. So some of those rules. Like one of the rules would be every wizard is not, so that implies that not muggle uh, X, right? So that's one of the rule that could be set. Another axiom, and so the example is if Harry is a wizard, then Harry is not a muggle. That's something that now the LLM can tell you. You just give it him wizard Harry Potter, and he can tell you, yeah, then it's obviously not a muggle. That's reasoning that you now gave to your LLM. So Dumbledore is a wizard. That's yet another statement I can express. So I'm now expressing this was the schema, and now I'm expressing the story as such. So this is a simple fact about Dumbledore. If someone teaches at Hogwarts, they must be a wizard and a witch. And I know the purists of Harry Potter will tell me, no, that's not true. There was a muggle, but it's for the sample, right? Okay. So this one says that teaches at Hogwarts. If X teaches at Hogwarts, then it implies that it's either a wizard, either or, right? It's a wizard or it's a witch. So if Dumbledore teaches at Hogwarts, then Dumbledore is either a wizard or a witch. Voldemort is an enemy of Harry. Harry is loyal to Dumbledore. So if someone is loyal to Dumbledore, they are not loyal to Voldemort. That's another way of expressing that. If Harry is loyal, okay. If someone kills another, then they are enemies. And then an example: if Voldemort kill Harry's parents, then Voldemort is an enemy of Harry's parents. If someone is a master of a creature, that creature is loyal to me. So that's this arrow that implies that. So you see now how you can start like to create rules about a knowledge base and how you can define the domain of expertise. This is about the story and loyalty and masters and wizards. And so now you are able to word that out in a formula way, but that is also translatable to natural language. I can write this out and I can also explain it like this. But this algebra or this formula is made of very simple principles to express it, and now I can manipulate it as it was math, as it was algebra, right?
And just
Uh,
so it really doesn't matter what you train the LLM on. Doesn't have to be that Boolean algebra. It could be the example you gave there. There's like almost an infinite number of ways to format this logic and feed it into the
yes, but the
LLM.
advantage of first order logic is that it's not new. It's not a wheel you reinvent. it's like you can tell the LLM like, hey, you can use Boolean logic, and he knows that because that's already like a well-known fact in his training data and so on. So when you tell an LLM like, hey, this is first order logic, these are my rules, he knows how to handle it. You don't need to train that on. You could create a DSL, so a domain-specific language of your own, but your LLM will be a total noob in that. So the fact we are relying on something very well known like the first order logic, it's something that you don't need to explain your LLM how it works. You just explain him the rules. You don't have to explain him the quantifiers, the logical connections, and so on. That's all well-known knowledge, right? So given these above 10 rows about the story and the way I've expressed my knowledge in this one, right? Now I can do some inferences on it. So on the statement wizard Harry, I can now like infer that Harry is not a muggle. In the teaches Dumbledore at Hogwarts, Dumbledore teaches at Hogwarts. So what can I infer from that, even though it's not stated explicitly? We can infer that Dumbledore is a wizard or Dumbledore is a witch. So now my LLM can ask, like, okay, you told me it teaches there. So, but is he a wizard or is he a witch? So now you can Google that out. Like, is Dumbledore a wizard? Is Dumbledore a witch? And you get an answer to that, and now you can approve or disapprove this link, and you can say, oh, okay, it's this one. So now you know that he's a wizard, and you can add that to your. That's content you just extracted by inference. You won't look it up. You have now a fact that proves that Dumbledore is a wizard. You can add that to your ontology, and then you run all your code again, and you do your inference again. But now your model is more intelligent. Now it can reason and know that Dumbledore is a wizard. So from a simple statement like this, and then there is a hypothesis that it's either one or the other, now you can fact check that and get a real fact out of that. Now, in the statement that Voldemort kills Lily Potter, then we can now know that Voldemort is an enemy of Lily Potter. And we can also say that the master. Oh,
Nagini?
sorry. So that's that. Yeah, that's another expression. Sorry. So the master of Nagini is Voldemort. So from there, I can infer that Nagini is loyal to Voldemort.
Nagini is Voldemort's
And
snake.
yeah, so but I was thinking that this was coming from this part, right? But definitely I went wrong in that copying somewhere. Anyway, so uh, if the master of Nagini is Voldemort, then we can suspect that Nagini is loyal to Voldemort, right? And if same goes for Harry is loyal to Dumbledore, then we can infer that Harry is not loyal to Voldemort because those are enemies, right? All make sense?
I got a quick question.
Yes, sure. Shoot in.
If in that logic, would the LLM interpret that Harry is Voldemort's pet?
No, not in that. No.
What's preventing it from doing that?
Well,
Is it because
it
there's
could
no
ask.
master of?
No, but it could ask it. It could like ask like, hey, so this one, yes, you could have another rule telling that loyalty is either because it's the pet of,
Mhm.
or because they have an affiliation to the same house, or that it's because Harry is a student too. So then you can say like if and only if, or you can say if it's one of these conditions. Things we have not defined yet. But what the LLM, it will tell you, or he can tell you, I have no rule for specifying the relationship between Harry and Voldemort, unless it would be his pet at this time. So I didn't find a logic, or it can't be a pet because it's two humans, right? So it cannot
Mhm.
be a pet of. At that point, he can tell you that there is inconsistency in your rules, and that he would look up for an explanation for that. So this will spot an anomaly, I would say.
Okay.
I guess is Is it always going to respond with like a one word response unless it's like a situation like you just explained where it can't do the logic? Like what does it output when it's the
Well, it,
logic
it will it
versus
will
the
answer to your question. So, and again, that's depending on your prompt. If you say only answer by yes or no, it will answer you. So, is Harry Potter loyal to Dumbledore? And he will then, depending on the text you give it to read, it can say yes, he is. So that's how that would be like a single word answer, right?
Wow. Yeah, that's very um modular.
Yeah, because you can ask it also like name all other situations. So you can do it by inclusion, by exclusion. I will show a little bit later on the fine tuning and the instructions, but I wanted to first add the logic to be covered by this. And as again, you have the link, so you can go through the bullet points and the takeaways, but that will basically just like repeat everything I've just said. Is that okay for everyone? And is it okay to move on to the next point right now?
Uh,
Yeah, this
sorry,
is awesome stuff and powerful.
Yes.
So
just one last thing. So it will it reverse so by axiom 8, for example, master of X, loyal to XY. Will it
Yes.
apply?
That
Will it
that's,
apply the reversal to it as well?
that you define that in the ontology too. So
Okay.
when you define loyal to, you can say that the inverse relationship or the inverse property of something is another property. So
Oh,
yeah.
okay. Nice.
So you can say like is child of, and then the reverse would be is parent of.
Okay.
And by defining that this one is a reverse, you only have to define one relationship. So if I say that I'm the son of my parents, right? Then my parents are my parents, right? Okay, so simple parent-child, child-parent relationship. If I say that the reverse is parent of for is child of, if I only say is child of, the other one is implied, right? So you don't need to express that all each time. The
Nice.
reverse can be implied and inferred by a graph database, and that's also part of the graph um, database capabilities, is to infer missing nodes and produce reverse nodes of that. Okay. Um, challenges that we have there. And I might be going to some code, but where the ontology helps, and I just said that, like we have some classes we are interested in, right? And we will define what the properties are. So, like I said, a human can have a date of birth, place of birth, and so on. So it's defining the schema on one side. And then on the other side, like we had with Harry is loyal to, these needs to be two humans, or the second need to be a human or a pet. That's a constraint you give to the model. So these are the domain and the range constraints you can give through an ontology. So that a company can be a subsidiary of another company, but not of a human. An founder of a company should be a human and not another company, right? So this way you can make sure that when you're extracting knowledge from your graphs or from your text and so on, it respects those constraints and that it's not hallucinating strange stuff, right? Are there still uh, questions that I might have missed in the chat? But no, I don't think so.
There's one that I didn't know how to answer.
it's not missing, but one of the things that's powerful about ontologies is the concept, and it's a basic one about triples,
Yes,
right?
and we'll
You
come to
have
that.
two entities, and you have a specific context for a relationship, and then you
Yes.
can fine tune by masking portions of the data. So that's why I said, I love this the thought concept, and if you're having a meetup related to it, I'd love to join and listening. So,
Yeah, I'm probably not a meetup, but yeah, I'll be online in the next days, and I think we are already friends. If not, just add one, and I'll be happy to have another
powerful.
talk
Yep. Thanks.
when needed about that. I mean, this is again, I just present the overall thing, the overall pictures. I know we are kind of like limited in time. I often go for talks for 2 hours, so I don't want to do to you this to you all guys. But definitely, I'll be happy to talk about it aside of that. Um, so I said we can now use deductive reasoning. We can do transitive inference, like a transitive property is, right? We can do subclass, superclass, and I will show class diagram a little bit later. Um, we can apply the logical rules right now. We can infer missing data. So if I know about two or three relationship and I know there should be a y or a z element somewhere in the equation and I don't have it, then I know that this is missing and I can look it up, right? So we can also use the ontology to do some disambiguation on top of it. And then we had that example that I've set up. So the ontology application of what we just saw above is that the LLM used to check it teaches art correctly links a person to an institution and so on. It verifies if Harry is a student, and then yeah, I should have added this one. Oh, the wizard and the part of the wizard and the wish one. Right? So this all gonna help because if you train your LLM to these ontologies and so on, it can start to reason about it. That's the most important thing because these axioms we have can be expressed in natural language and they can be like formatted in a easy way to do that because you got these quantifiers, then you got the rules, so you can write them all out, right? So these are more examples and so on. So I'll let you guys like check that out. I just like have added
The boss,
and this is
can I
yes,
add?
yes,
Right. So the fact that it's not only useful in the fact that you just said, but also in the fact that it's a very clear answer. The way that Sebastian has structured this is it's good if you need high validation on your data. Where does it come from? Are you sure this is the reality of things? So
yeah.
normal LLMs they
Using
generate too much, right? So in the way that he has done it right now, you can ask validated questions, and this is also why this is so cool. I'm very
yeah.
proud of what Sebastian
Yeah,
made.
agreed.
So yeah, accuracy, inference, checking things like all these keywords are like in the and my best analogy here is an ontology is what makes your LLM go from zero to hero as a domain matter expert as long as you give it the good knowledge, right? So yeah, and a good thing also is that ontologies exist for a long time. So there are already ontologies called like friend of friend, which are defining relationships between people, like for example, parent child, if they are friends or in a relationship, spouse and husband, and all these kind of things. There are already ontologies for that. There are ontologies for defining company relationship whenever someone is a subsidiary owned by or a part of or a holding. What is a holding? What's a company? What's a non-governmental organization and so on. There are already a lot of ontologies around defining all that, so you can pick up pieces of that. You can reference ontologies, and I will show you how schemes can be mixed up so that you make a big domain that mixes up a couple of ontologies about medicals, about chemicals, about your own Harry Potter story, whatever. So you can build up your domain using already existing pieces and parts like a Lego block, right? If I zoom into this one is like a representation of the supply chain ontology that we have, right? And so you have a partners with a supplier. A supplier maps to a warehouse, and then it has a product line that is given by the product by the supplier. Sorry, an office can be a plant or it has logistics and so on. So you have a class diagram with all these triplets explained and how something links to another, like warehouses, shipments, um, and so on and so on, right? Distributor, transport via transportation route, it delivers some delivery, there are products involved into the process, and so on and so on. So you can represent that all in graphs, class graphs, and so on. I guess no other questions, right? So now, given my LLM is able to extract knowledge, given my user is able to ask questions, now is the fact that I need my LLM to be able to answer questions, understanding the user's query and build up on that, right? So the first step in understanding the user query is doing some entity recognition. And again, we have defined in our ontology which was a character, which was a location, and so on. So that will help the model know what kind of things it should ask and what are the relationship between the classes you're asking. So the intent will be defining what the user is trying to find out, and so which relationships you need to start to query and which attributes you need to query. So, if the user asks which house does Harry belong to, then an entity is Harry, and then the intent is finding Harry and the house belongs to. So now we can start to map that to a query. And so now it would be like person, and the intent is belongs to. So now I can generate what's called a cipher. You can compare that to a SQL query, but then for graphs. So now what I want to find is the match between n and the label given a particular relationship. So which house does Harry belong to would be like match Harry as a person belongs to house. That's the query I will ask. Okay, if you would map that to a SQL, is where Harry dot name, where the person dot name is Harry, and then it would return the house name you want to have. So a cipher query would look like this. Harry being a variable, right? So it could be X here. So X should be of the class of a person, and Y should be of a class house. That's how it works out basically. So X belongs to Y, and you already define what class, what type X should be, and what class house should be. And now, if there exists a link in your graph that does that, it's gonna check like, okay, but the name of this person should be Harry, and what I want to return is the house, a property named of that. All make sense? Yes, it all makes sense. So, what will be returned from this is a relationship, a triplet between these and the house name. And so the model will return Gryffindor, but your LLM will make an answer that is much more like the user want to see it, is Harry belongs to the Gryffindor house. Okay, so what an LLM, when used with graph rags, graph networks, will do is that it will take your initial question, it will identify entities, it will identify the intent, and then so what the query would be totally, so identity, the entity, then your intent here of the question, it will map that out to a cipher, execute the cipher against the database, get back one more values, whatever the output should be, and based on that, it will rephrase that in a natural language expression for you, right? There are much more complex queries you can do. You can do multiple relationships out of it. You can do aggregations. You can do pattern matching, and so on and so on. So you can do who are Harry's friends that belong to Gryffindor. That would be mapped like this. So again, X is a person, and I want to know it's a friend of another person, and I want them all to belong to a certain house. And then I'm gonna tell that the Harris or the person's name should be Harry and that the house should be Gryffindor. So we are trying to find everybody that's a friend of the first one, which also matches to the second one. Does that make sense? Yeah. Okay. Continuous learning. That's like up to coming is that once you have all that, you can like vote with thumbs up, thumbs down in the feedback iteration to improve your knowledge graph over time. Um, that's basically it. Again, the bullet points are there, guys. I suggest you take a look and go that on. I will continue because we got a little bit more to see about this. So now how do we apply that in supply chains? Well, we create also entities. Entities, that's my nodes of my graph. And I got a supplier, companies or entities that provide materials or components. I got manufacturers, entities that produce goods from raw materials. I got distributors, which are entities for distributing products to retailers and customers. So I got retailers. So we have products and then locations because the warehouses, distribution centers, and factories, retail outlets, they are all somewhere located, right? And now when we got all that, then we can imagine what transport routes are between these items. So you see now how all these nodes start to like make a graph and how you can all represent them. Um, then you got all the relationships. So a supplier supplies connects the suppliers to manufacturers. The manufacturers, so the verb manufacturing, right? So if X is manufactures Y, then that connects manufacturers to products. Distribution is manufacturers to distributors. Located at like any factory, warehouse, and so on is a specific location. And then you got transports, which again predicate that's mapping the transport routes to products and locations. So we can use ontologies for that. Again, consistency, validation. We can check that things we extract, but also that our ontology is valid and coherent together. So questions we can start to ask is who are the suppliers for product X? The LLM will identify that we are looking for suppliers nodes, that we want them to connect product X via the supplies relationship, and so on. So I can now like build this as a cipher and go on like what are the transport routes for delivering product Y to retailer Z, and then we have here also a query, right? So on one side, you have the knowledge extraction, where we told them like, hey, this is a product, this is a transport route, this is that. It extract nodes, put that all in a database, and now you have like the reasoning part where the user starts to ask some questions, and we will phrase that into queries, knowing the ontology, knowing what kind of relationship we are looking for, and getting results out of that graph database. And then we can in an agent framework, we can like ping pong that to the one and the other so that they make a very complex answer, emitting some hypothesis or emitting some knowledge, validating it against the axioms, coming back and forth until they get a satisfying result, right? Okay, much more complex queries. Again, let you read that all if you want to go more in details, and that's it. Still no questions or
Nice.
nothing more? Okay. Um, I get like move on to the next one. Um, Something that we were challenging basically is that at some point your ontology is gonna be big. It's gonna be a lot of rules, and the RDF format is not that kind of tokens aware thing and so on. So yeah, you want to reduce the fact that you always need to repeat your ontology in your context. And you're gonna have also a lot of rules, and you're gonna have different tasks, and you're gonna have a lot of information that you don't want to repeat each time when doing some fine tuning. So you want to generate a data set, and maybe I can go on to the data set. You will find a link on that, but I made some data sets and some models too, but this is the one. So we have a data set with like basically instruction, input, and output, right? Let me go to the data set view. So these are examples that now my were generated with Gemma 2 about the address class. And so you are a helpful AI assistant that helps users with the supply chain mapping ontology. Please provide a concise but complete and clear answer to the user about his input question. And then what is an example of the supply address? And this is a turtle formatted. Now, another one is like, and this is the place where the axioms gonna be given to the model. So can you give me the first order logic axioms of the address class? Then the next one is explain the first order logic. And then the axiom states that something is an address if and only if there exists a location that is identified by address X. In simple terms, an address always refers to a specific location. This is a generated dataset based on the axioms I showed you. So I can now write a full explainable text based on that formula that we had here, right? This is what I have, but I'm very able to generate this out of it. But now that this is fully written out, my model is able to make assumption links and reason about that because it was explained not only in first order logic, but also in natural language, right? So you got this also like what's the difference between an address and a location in the supply chain, and it will explain you counterexamples or more deep sorry, a more detailed explanation about it. um, Give me an example of valid supply address in the supply chain. This is a valid formatted one. It has the country, the city, and so on. What are the properties of it? The class are street, city, region, country. So you see how from one class I'm been detailing it and providing all that training information to my model so that now it's able to reason about it, understanding, question, challenge what the entity is, right? I'm not just giving the ontology definition as such. I make a full set of question and answers about that specific class. And I do that for all the classes that exist in my ontology. So now I don't need to repeat my ontology in my prompt. Previously, I was obliged to put like a piece of text I want to analyze and the entire ontology behind it. Um, this is the this is each time I'm trying to follow on the chat, but yeah, that's one of the data sets. There are others, and there's a link in the very beginning of my talk about ontologies training data sets. Then there is also like a Q&A, question and answer data set. So look at it. They have different amount of pairs being generated and so on. So yeah, give it a shot, give it a look. The ontologies definitely are applied to what I want to do, but they can be yeah, much more extended and so on. I told in my example that we were also generating the UI for the user. And you know what? Well, that's also defined in my ontology. Where was that one? That's also defined in my ontology. Let's go here. So, for example, I define a class which is a chat widget. And so I explain in my ontology what a chat widget would be, what a chart widget would be, what an API is, what a CSV file is, what a widget container that can contain other things. So I also explain um, my in my ontology language what my relationships between elements are and so on. So giving this, my LLM is now also able to produce the UI I want to I want to get from it, right? Does that make sense? I define like what AI models are, what a prompt is, and so on. So now I can make my AI a domain matter expert of AI itself, of the UI itself, of how my application is working, how my CSV files are formatted and representing my data. Okay, what is PDF file, and so on, crew, and much more. Okay. Any questions so far? Anything clear, unclear? I'm trying to speed up and wrap up because at some point, I think we need to close. Sarisha, are we still good on time there?
Yeah, I mean, we technically have a minute left if there's something you want to, like one more thing you want to share, or if you have a little bit more of a demo that you want to just present to us. Other than that, though, I want to honor everybody's time today.
Yeah, so again, the notes are available, the repo is available, the models are available. Definitely, there's much more to say, but I've made a contribution to Onslaught for training, fine-tuning. So these data sets were used to fine-tune models already, so you don't have to bother to do them. But so if I go here in SCM, you will find a couple of models like 5.3 on 16K window, Llama 3, and so on and so on, made for SCM, so for the supply chain mapping. I've also put the LoRa's out there. Yeah, I think there is much more to show and to say. That's why I didn't want to dig out into demos and much more about the concepts. I hope it was still interesting for all you guys. And yeah, that concept was interesting enough for you all, right?
Yeah, man. I
Yeah.
think that Boolean logic is basically this is the key to making your
Oh yeah.
LLM do what you want and giving it reality space.
The last thing, maybe, and the most important, because pictures are like the most amazing thing I can show you, is like the outputs we got out of it. So, what is the supply? The question was asked, what is the supply chain of Levi Strauss? And this is the kind of outputs it can generate. So this is more a mind map than a graph, but on the level of distribution, there is warehousing, transportation, and then you got the companies like who does the freight management for Levi Strauss? It's UPS and FedEx. Who is like how do they source their cotton? Well, they participate to the Better Cotton initiatives, and they are using Cotton USA to do that. And then they have also fair trade and so on and so on. So I'll let you guys the charts are there, so look at it. But this is the kind of outputs that our model can generate when we ask him like what does that company do on sustainability and so on. So here you see all the nodes, the relationships were selected and selective, but yeah, that's what we can produce as kind of outputs with the app. And yeah, I think that's like closes it all. Floor is yours.
Yeah, thank you so much, Sebastian. This is awesome. And Sebastian, you are always welcome back. So, um,
Thanks.
yeah, you're definitely welcome back. It sounds like you have more to share. It sounds like there's more that you're working on. And just based on attendance and everybody just chopping it up in the chat, I think people would love to hear more of what you're building. And so for folks on the call, if you haven't yet, please connect with Sebastian. He is a community member. He also is active with Borch's community. So please interact with him, get some links and some extra readings. If you on the call, if you're working on something cool and you want feedback, you want to do a little bit of Q&A, please shoot me a DM at Sriracha. I'd be happy to set up a community session for you. This is for the community by the community. It's all about giving people the platform to be able to share what they're working on, get feedback, advice, and be able to connect with each other and support one another. So, thanks everybody for coming. And yeah, look forward to the next time we have a session. I think in about a week or so, we're going to have a session from Jacob, who's actually on the call. So, look out for that. And yeah, thank you again, Sebastian. This was awesome.
No problem. And I will not leaving right now. So if people wanna talk in the community in the lounge here, I'll be still online. So we can have an open chat about whatever you want, guys. Yeah, thank you so much for giving me the place to express that, to show that off. I hope it was like I saw it was interesting for everyone. So very very thankful for that. And yeah, be there for more questions and answers.
Awesome. Thanks, everybody. And yeah, Sub's staying around, so feel free to hang out in the lounge. I'm going to bounce out right now, but yeah, hit me up if you want to share on a community session. And thanks again, Sub. I will talk to you soon.
Awesome.
Welcome.
Thank you, Sarah.
Bye. Thank you. Bye, Borsch. Bye,
Bye
guys.
bye. Bye bye.